Hello, Miss Thinker here. Your daily source for mind-blowing facts, forgotten history, and powerful motivation. Right now, you're traveling through space at over 1,000,000 kilometers per hour. But that's nothing compared to what's possible. What if humanity wanted to cross the entire universe? Not in millions of years, not in thousands. But as fast as physics allows, what is the absolute fastest way anything could travel? And could we ever reach it? Let's explore the ultimate speed limit of reality itself. Space is unimaginably big. Our home galaxy, the Milky Way, is about 100,000 light years across. That means if you traveled at the speed of light, the fastest speed anything can go, it would still take 100,000 years to cross it. And our nearest large galactic neighbor, the Andromeda Galaxy, is about 2.5 million light years away. Even light itself needs millions of years to make that journey. So the real question isn't just, how do we travel fast? It's, can anything travel faster than light? According to physics, the maximum speed in the universe is about 299,792 kilometers per second, the speed of light. This limit was discovered by Albert Einstein in his theory of relativity. His equation showed something incredible. The faster an object moves, the more energy it takes to accelerate it. As you approach light speed, your mass effectively increases. To actually reach light speed, you'd need infinite energy, which means no object with mass can reach or exceed the speed of light. So does that mean intergalactic travel is hopeless? Not necessarily, because physicists have imagined ways to bend the rules without breaking them. Let's start with real spacecraft. The fastest human-made object ever built is NASA's NASA Parker Solar Probe. At top speed, it reaches about 700,000 kilometers per hour. That sounds insanely fast, but compared to light speed, it's only about 0.064% of it. At that speed, crossing the Milky Way would take over 150 million years. Clearly, rockets alone won't get us across the universe. We need something radically different. Scientists have proposed several possible ways to travel across cosmic distances faster than conventional motion. Let's explore them. A warp drive doesn't move a ship through space. Instead, it moves space itself. The idea is simple but mind-bending. Compress space in front of the ship. Expand space behind it. Ride the wave. The ship technically isn't moving faster than light locally, but space carries it faster than light relative to distant observers. This concept is called the Alcubierre drive, proposed in 1994. Problem? It requires exotic matter with negative energy. We don't know if that even exists. Wormholes are theoretical shortcuts through space-time. Imagine folding a piece of paper so two distant points touch. Instead of traveling across the paper, you go through it. If wormholes exist and could be stabilized, they might allow instant travel across billions of light years. The challenge? We've never observed a real one. And keeping one open might require more energy than an entire galaxy produces. This one is real physics, not science fiction. At speeds near light speed, time slows down for the traveler, meaning a crew traveling at 99.999% light speed could cross the galaxy in their lifetime, even though thousands of years pass outside. From their perspective, the trip feels short. From Earth's perspective, it takes millennia. So, what is the fastest possible way to cross the universe? Based on our current understanding of physics, the fastest possible method is bending space-time itself. Not accelerating, not engines, not fuel, but manipulating the fabric of reality. If advanced civilizations ever discover how to control space-time geometry, they could effectively travel anywhere instantly. Not by moving fast, but by making distance irrelevant. There's one final twist. Even if we master warp drives or wormholes, the universe itself is expanding. Some galaxies are already moving away from us faster than light due to cosmic expansion. That means there are regions of the universe we can never reach, not because we're too slow, but because space itself is stretching too fast. Those galaxies are permanently beyond our reach. So what's the fastest way to travel across the universe? Not rockets, not engines, not even light speed. The ultimate answer might be, don't travel through space at all. Travel with space, because in the end, the real barrier isn't distance. It's the laws of physics themselves. And until we learn how to bend those laws, the universe will remain the greatest frontier we can see, but may never fully cross. Have you ever stared up at the night sky and wondered how it all ends? We've talked about how the expansion of the universe limits our cosmic travels, but what does that expansion mean for the universe itself? Let's explore the ultimate cosmic finales. One leading theory is the Big Freeze. Imagine the universe continuing to expand forever. As galaxies drift further and further apart, the cosmos grows colder and darker. Stars will eventually burn out one by one like cosmic candles being extinguished. After trillions of years, even the last embers, the black holes, will evaporate through Hawking radiation. The universe will become a vast, frigid, and near-empty void, a quiet graveyard of what once was. In this scenario, the end isn't a bang but a slow, silent fade to black. But what if the expansion doesn't just continue, but accelerates uncontrollably? That brings us to a more dramatic ending, the Big Rip. In this scenario, the mysterious force we call dark energy becomes so powerful that it overwhelms gravity. First, it will pull galaxy clusters apart. Then galaxies themselves will be unbound, sending stars flying into the void. The pull will get stronger, tearing planets from their stars and moons from their planets. In the final terrifying moments, the fabric of space-time itself will rip apart everything, right down to the individual atoms. It's a violent end where the universe is torn to shreds. Both of these scenarios paint a picture of a lonely future. Which brings us to a profound and unsettling question for the present, the Fermi paradox. Our galaxy alone contains hundreds of billions of stars, and the observable universe contains hundreds of billions of galaxies. The numbers suggest that intelligent life should be common. So, where's everybody? Why haven't we detected any signals, any probes, any evidence of other civilizations out there among the stars? Are we truly the first? Or perhaps the last? Maybe advanced civilizations are rare or they don't last long enough to make contact. The silence of the cosmos is deafening. It forces us to confront the possibility that we might be utterly alone in this vast, dark expanse. This cosmic solitude, combined with the universe's ultimate fate, makes our own existence here on this small blue dot all the more precious and fragile. What we do now in our fleeting moment in the cosmic timeline truly matters. Ever look up at the night sky and think you're seeing everything? Well, it turns out we're only seeing a tiny fraction. The vast majority of our universe is invisible, made of two mysterious components, dark matter and dark energy. First, let's talk about dark matter. We can't see it, we can't touch it, but we know it's there. How? Because we see its gravitational effects. Imagine a spinning merry-go-round. The stars on the outer edges of galaxies are moving so fast they should fly off into space, but they don't. Something is holding them in place. That something is the extra gravity from dark matter, the invisible cosmic glue that holds galaxies and galaxy clusters together. Without it, the beautiful cosmic structures we see simply wouldn't exist. But the universe's mysteries don't stop there. While dark matter pulls things together, another force, dark energy, is pushing everything apart. In the late 1990s, astronomers made a shocking discovery. The expansion of the universe isn't slowing down. It's accelerating. Dark energy is the name we give to this repulsive force embedded in the fabric of space-time itself, causing the cosmos to expand faster and faster. This leads to an even more mind-bending idea, the multiverse. Some theories, like cosmic inflation and string theory, suggest that our universe might not be the only one. Imagine an infinite cosmic foam, where new universes, each with potentially different laws of physics, are constantly bubbling into existence. Our entire cosmos could be just one bubble in an endless ocean of universes. It's a humbling thought that highlights just how much is still out there, waiting to be discovered. Thanks for watching. If you're fascinated by these cosmic questions, make sure to subscribe for more journeys into the unknown.